A hexagonal prism having a base 30 mm side and axis 70 mm long has its edge on base in VP. Its axis is parallel to HP. Its base surface is inclined 30 degrees with VP and perpendicular to HP. Draw its projection. In the previous question, the edge of solid is resting, so it gets projected on step 1 only. In this problem, axis inclination is given, so this problem will require step 1 and step 2 to get its final projection. Firstly, write the given data in a drawing sheet. Length of base side is equal to 30 mm. Length of axis is equal to 70 mm. Axis is parallel to HP. Base surface is inclined at 30 degrees to VP and perpendicular to HP. Edge is resting on VP. Okay, let's go to the initial step first. Step 1. It is given in the problem that the base surface is perpendicular to HP, so its base should be drawn above XY. In this position, the true shape of the base can be seen only from the front view. So we start drawing the projections beginning with the front view first. The front view is seen as a hexagon, so draw the front view in hexagonal shape with the side of base 30 mm such that its edges 5-6- and 3-2- is perpendicular to XY. This is the front view in the initial position. Next, we are projecting the top view. The top view of the hexagonal prism looks like a rectangle. So let's draw the top view in rectangular shape with a height of 70 mm touching the XY line. And we get the base of a rectangle from extending the construction lines from the corners of the front view. And draw the axis line in the middle from the intersection point of 1-4- extension line. Let's give lettering to the corners of the prism. Assume corners of the hexagon in front view as 1-, 2-, 3-, 4-, 5-, 6- and corners of the hexagon in top view as 1, 2, 3, 4, 5, 6. So the top view should be named as 556611442233 without dashes. And the front view top should be named as 5-5-, 6-6-, 1-1-, 4-4-, 2-2- and 3-3-. Now we will see how step 2 should be drawn. It is given in the problem that its base edge is inclined at 30 degrees with VP. So we are going to just tilt the step 1 top view at 30 degrees angle. Let's draw a 30 degree line below XY using a protractor. Now shift the edge 2, and 3 on the 30 degree line by measuring its length from step 1 such that the corner 2 and 3 lie on XY. And the other end becomes 5 and 6. In the step 1 top view, we can see that the base is perpendicular to the rectangular side lines. So draw the perpendicular lines 2, 5, 6, and 3 with the length of 60 mm. Draw the line 2, 5 and 3, 6 by measuring it from the top view of step 1. We can see that in the top view of step 2 rectangular shapes are formed. Now draw the axis line in the middle and mention the other letterings. This is the top view of step 2 in which edge is inclined at 30 degrees to VP. Now we will draw the front view for the inclined position. For that we have to draw extension lines upwards from all the corners of the top view. And now draw the extension lines right side from the front view of step 1 intersecting the vertical lines. Let's join the intersection points in accordance with the front view of step 1 so that we will get the hexagonal shape of the base surface of the hexagonal prism as the front view in inclined position. And also join the intersection points to get the bottom surface of a hexagonal prism. Now join the rectangular edges accordingly and draw the axis line in the middle. We can get this by extending a line from the midpoint of front view in step 1. Give proper lettering to all the corners. We cannot actually see the backside portion of the hexagonal prism, so make them dotted lines. We can now see the axis of hexagonal prism obtained in step 2 is parallel to HP and its edges are inclined at 30 degrees to VP. The obtained front view in step 2 is the true shape of hexagonal prism satisfying all conditions as per the problem. In this video, we have seen problems that can be projected in step 1 and step 2. We have projected the solid in step 2 by extension of parallel construction lines. As we know that the method of projecting objects by extending parallel lines is an orthographic projection, so these problems are examples of orthographic projection. In the next video, we will see some more problems with orthographic projection. We will study a combination of problems which we have done today. It means in the next video, we will solve problem that can be projected in 3 steps. Projection of regular solids. Previously, we have discussed the projection of regular solids that can be completed in step 1 and step 2 only. We have done 2 problems in the previous video of projection of solids. In this video, we will be doing some more problems that can be projected in 3 steps. A pentagonal pyramid of base 25 mm side and axis 50 mm long has one of its triangular faces in the VP, and the edge of the base contained by that face makes an angle of 30 degrees with the HP. Draw its projection. Now here in this question, pyramid can be projected in 3 steps. Note down the given data in the drawing sheet. Base side of pentagonal pyramid is 25 mm. Axis length is 50 mm. One face of the pentagonal pyramid is resting in the VP, and the edge of that face is inclined at 30 degrees with the HP. Now let's start with the initial position, step 1. As it is given in the problem, one face of the pentagonal pyramid is resting on VP, and the edge of the base is perpendicular to HP. So the front view will be drawn firstly. The front view of the pentagonal pyramid is the pentagon, that is the top and bottom base of the solid. After drawing a front view, we will project the top view from it. Draw pentagon above XY such that its one edge 1 5 perpendicular to XY. Now draw the pentagon of side 25 each by using a compass, and angle between the edges of pentagon is 108 degrees. With the help of this data, we can project the front view, that is the pentagon. Name the pentagonal face of the pyramid as 1 2 3 4 5 and mark point O as its centroid. We know centroid can be pointed by intersections of median, so we can point its center easily as O'. Then we will project its top view. The top view of the pentagonal pyramid is triangular in shape. Its top view can be projected by extending the parallel construction line from the front view. As given in the problem, the length of the axis is 50 mm. So draw an axis of 50 mm length. We will get the O vertex of the top view, and the other vertex 13524 can be projected from the front view on XY as shown. Join O1 and O3. We can see the triangular view of the pentagonal is projected. This is the required top view of step 1. Here step 1 gets completed. Now moving to step 2. It is given that one of the triangular faces of the pentagonal pyramid is resting on VP. So change the top view in step view. For that, shift the line O1 for the face O15 in reference line XY and shift the other faces by measuring length from top view of step 1 with the help of ruler scale. Now we have to project the front view of step 2. For that, draw the parallel construction line from the corners of the front view of step 1 towards the right side, and also extend the parallel construction line upwards from the top view of step 2. Now we can analyze that all construction lines will intersect each other at some point. Give nomenclature as to the front view of step 2 as per the top view of step 2 and front view of step 2. Like the point where construction lines O' from step 1 front view and O from step 2 will intersect, give that point name as O1'. Similarly, other points can be obtained. Here we can clearly see the pentagonal prism in step 2 front view with base 11-, 22-, 33-, 44-, 55- with 5 triangular faces. We cannot see the 3 faces that are the back portion of the pentagonal prism, so we will draw 1-, O1- and 5-, O1- with dotted lines. This is the front view of step 2. Now moving towards step 3, that is the final step. In the problem, it is given that the edge of that face which is lying on VP is inclined at 30 degrees with HP. For that, make a 30-degree angle line with reference to XY. Now shift the line 11-, 5-, on the 30-degree angle line so that 11-, 5-, will make 30 degrees to XY. Shift the front view of step 2 by using ruler, scale and compass. Remember, we have shifted the solid. The measurement of step 3 front view should be the same as step 2 front view of step 2, so no measurement should get changed. So tilt the front view. Give numbering to the corners. This is the required front view. Now we have to project the final top view of the problem. For that, draw the construction lines downwards from step 3 front view and toward the right from step 2 top view. Now we can analyze that all construction lines will intersect each other at some points. Give nomenclature as to the top view of step 3 as per the top view of step 2 and front view of step 3. Like the point where construction lines O1- from step 3 front view and O step 2 front view will intersect, give that point name as O1. Similarly, obtain other points 11, 22, 33, 44, 55. This is the required final top view. We cannot see the back portion of the pentagonal prism, so draw 4151 with dotted line. This is the final projection. Now we can see that one face, that is O15, is resting on XY as per the problem. The final projection of the solid is the top view of step 3.